guys, so today we're going to be working on 7.7 trapezoids. Oh, what's that in the corner? Oh, I think we have a little friend who's joining us. This is a fish. This fish is confused by math. Hi, Biff. What? Oh no, you're stuck in a trapezoid trap. Okay, let's start out with the trapezoid rule. So the rule states that the integral from b to a of f of x dx equals the change in x over 2 times f of x naught plus 2 of f of x1 plus 2 of f of x2, where the change of x is b minus a over n and xi equals a plus I times the change of x. Yeah, what is right? But never fear, there's always an easier way to understand. We already know the equation for an area of a trapezoid. Just look at it this way. H equals the change in x, and the b1 plus b2 is just you're adding the two y coordinates together of the trapezoid you're going to be making. See? Life makes sense again. Now here I am talking about trapezoids, and we have no idea what we're doing still. So, what does it look like? It looks like that. You have a graph, and then you connect 2 points, bring a line down, and there you go. You got a trapezoid. Okay, why don't we try and do some practice problems? What is the area of the graph when n equals 5? And here's the graph we are given. Now before we start drawing anything, we should probably know what are we doing with n equals 5. Well, n is the number of how many trapezoids that we are going to be putting into our graph. So we have to split the graph into 5 equal parts. Since the number is 5 and we have 5 intervals, all of the intervals are going to equal 1, and that's what it'll look like. Now let's plug it all into the equation and find out how to figure out the area. So we start out with the area of the trapezoids equals 1/2 times 1. And you get 1 from doing b minus a over n. Remember that b minus a are endpoints and not the different x's throughout the interval, because if you mess that up, then you can get the entire change of x wrong. So it's easier just to remember it as the two endpoints and not just the x's throughout the interval. Then you multiply it by the bases. So 5 plus 2 times 4 plus 2 times 1 plus 2 times 2 plus 2 times 3 plus 1. You multiply the middle number by 2 because if you stretch it out, you get 5 plus 4, 4 plus 1 plus 1 plus 2, and so on and so forth. Then you would simplify it further to get 1/2 times 9 plus 5 plus 3 plus 5 plus 4, which will then give you your answer of 26 over 2, or simplified 13 units. See, it's not that hard. Even Biff gets it. How about we try a new type of problem? You're given an equation and then you have to graph it to figure it out. You are given the integral of 2 to 0 to the 4th root of 1 plus x squared dx, and n equals 8. And the graph more or less looks like this. Since n equals 8, you have to split it up into 8 different trapezoids as shown. To start out, you get a equals 1/2 times 1/4, because 1/4 is the change of x. And then you multiply by the equation 1 plus 2 times 1.02 plus 2 times 1.06, so on and so forth. Once you add and multiply up everything together, you should get 1/8 times 19.36. If you multiply those two together, then you get 2.42 units squared, and what's really cool is if you plug this integral into your calculator, you get 2.42 rounded as well. And it's that easy. Okay, let's try a different type of problem. This one does not involve a graph, you are just given the information. The problem states to use the trapezoid method to estimate the total distance. So someone's gonna be running or, dancing. I don't know, can you dance in the distance? Probably. And then you are getting a handy dandy table with a bunch of information on it because tables are really cool. No, Biff, love the tables. They give you everything you need. So to do this problem, just apply the area equation. The table gives us all of the information, so what we can take away from it is that n equals 10, so that means if we were to graph it, we would make 10 trapezoids, but we also know that we need to divide our change in x by 10. Our change in x is 1/2, and you get 1/2 because the endpoints are 5 and 0, so 5 minus 0 is 5, divided by 10 is 1/2. So with that information, we can move on to plug it into the actual equation. Then you add and multiply everything together from the points on the table, and you get this really long equation that looks really hard, but it's actually not. And when you add and multiply everything together, you can simplify it down to the area equals 1/4 times 177.95. Then you multiply that together and you get 44.49 meters. And that's how you do the tabular problem. You're right, Biff. That problem isn't so bad. Even though you're not giving a graph, you can take advantage of all the information that the table has given you, and you can figure out the area through that. I hope this video was able to teach you how to do trapezoids and that you were able to get the help on any little parts of it that you didn't understand before. Thanks for watching, and I hope to see you next time.